So we now want to discuss CVP, the cost volume profit analysis. And I gave you the notes on the same. So we are just going to go through them quickly and proceed on. Now, when we talk about CVP, it is the study of the relationship that exists between the costs, the units produced, the revenue, and the profits. That's what we call CVP, is a study of that relationship. Traditionally, it used to be known as break-even analysis because it was about the determination of break-even point. And break-even point is the method at which total revenue is equal to the total cost. That is what we call break-even point. It is the point at which no profit or loss is made. Now, in the modern day business environment, which is very, very competitive, CVP analysis has become more popular than break-even analysis because CVP is able to supply more information. And for you to survive in a competitive environment, you require more information. Now, CVP is divided into 4 areas. As you can see, we are first of all dividing in terms of the conditions, certain conditions, and certain conditions. Certain conditions are conditions where we are sure that this will happen or this will not happen. And certain is when we are not sure. And the certain is what we call deterministic, just like what we had when we were in inventory. And certain is also called probabilistic. You can also call it stochastic. Now, each of these is done in regard to a single product and multiple products. So that is how we have the 4 of them, and we'll discuss each one of them. Now, for the single product, certain conditions, CVP analysis, this is where a company is producing and selling just one product. Producing and selling just one product. And the factors which are affecting profits, they are well known in advance and they remain unchanged throughout the analysis period. Remember, I've been telling you that when you are in advanced management accounting, you must be keen to pay attention to the period. Which period is being considered? And in most cases, it is 1 year. Now, the specific assumptions that we have in this CVP for the single product certain, one is that the relationship between the units produced, the costs, revenues, and profits is linear. Now, because of that, when we draw the lines, they give us very straight lines when we draw the graphs. Number 2, we assume there are no scarce resources. That means everything we desire is available. Everything we desire is available. We do not have any constraints. That the other one is that demand is equal to supply. What we have supplied is what the customers will demand. So we do not have cases of stocks. Stocks arise when you produce more than what the customers want. So unabaki na some units. Neither do we have shortage costs, as we were discussing the other day, because shortage costs arise when you have produced less than what customers are demanding. The other assumption is that fixed and variable costs can objectively and accurately be separated. And this is what we said when we were in the topic of cost forecasting. Ukasema total cost is equal to fixed cost plus variable cost. The other thing is that total fixed costs, the unit variable cost, the selling price, and the level of technology, they remain unchanged. So they are not changing. They remain constant within the period of analysis. Now, the above assumptions, if you are to look at them from a practical viewpoint, they become limitations. Because, for example, you cannot operate a business all through where demand is exactly equal to supply. There are times they will be equal. There are times when demand will be more than supply. And there are times when demand will be less. That's why we will always have talks, either closing, opening, and they keep on changing. When we say that technology, prices, and the others are not changing, that is also not practical. Now, in this case, if these assumptions are maintained, this is how we derive the formulas. We say X to be the unit produced and sold. Contribution margin is CM, P minus V. P is the selling price. CMR is given as contribution margin. You divide by the price, which is contribution margin ratio. R is the revenue, price times the units. VCR, the variable cost ratio, is given as the variable cost you divide by the price. And it's good to note that CMR plus VCR is equal to 1. Now, V represents the variable cost per unit. F represents the total fixed costs. Then XBE is the break-even point in units. MOS is the margin of safety. That is the region within which a company does not make losses. Pi M, that is supposed to be the symbol for pi. In my typing, it did not come out well. But when we are doing formula, we are writing, it will come out well. Profits made. Pi T is target profit. RBE is the break-even point in shillings. Then we have two approaches that we use. These tables or these letters to represent all that. There are two approaches. One is graphical. The other one is algebraic. Now, algebraic, we will be developing those formulas. We'll be using them. Graphical, we draw graphs, but at this level in section 5 or in advanced level, we are not supposed to draw graphs. You people, you are senior guys, you are just supposed to interpret. Graphs you drew in management accounting section 4. Now let's look at multiple products. Now multiple products is a situation where you are selling more than one product, but the conditions remain known. Now, in this case, we use the concept of weighted averages. So in using the concept of weighted averages, this is how we revise. We will be doing a question. Maybe that's when it will make sense. For now, it just looks abstract. And we are doing so because the fixed costs are treated as a single figure. But if the company is having fixed costs, which can be separated, then you treat the various products as singles, is what they call singles, separately, and severally. Now, from there, we have what we call the stochastic CVP. Stochastic is where now the factors that affect profit, they keep on changing. They are probabilistic. And if they keep on changing, we now use the concept of expected values. This one, XI multiplied by probability of XI. And in that case now, the profit will be computed like this for single product. And for multiple products, this is how to be computed. We will be applying this formula. That's when they will make sense. And then if you have two products, this is something we call the expected values for the profits. This is the formula we use. Again, for now, I know it looks abstract, but we are getting there to do a question. It will make sense. That's all. That's about the notes on CVP. So I want us now to get to the questions so that we can apply those concepts as we go by and by. So I hope we have followed that discussion. Good. If you have any query, you can raise as I look for a question that will start as all. Okay, so looking for a question. Let's go to this question of May 2002. Question 1. May 2002, question 1. May 2001, question number 1. We can request Christine to read for us. But I'm only interested in part A and B. And C. Christine, have you gotten it? May 2002.
1 or 2?
2002. May 2002, question 1.
New Books Publishers Limited are planning to introduce a new management accounting textbook. The company's management accountant estimates that the initial distribution for likely sales is normal, with a mean of 20,000 books. In addition, it has been determined that there is a probability of 0.5 that the likely sales will lie between 16,000 and 24,000 books. The textbooks will sell for 1,000 shillings per copy, but the publishing company pays the author 10% of revenue in royalties, while the fixed costs of printing and marketing the book are calculated at 2.5 million shillings. Using current printing facilities, the variable production costs are 400 shillings per book. However, the NBP Limited has the option of hiring a special machine for 1.4 million shillings, which will reduce the variable production cost to shillings 250 per book. Part 1A showcase the standard deviation of likely sales. Show the standard deviation of likely sales is approximately 6,000, and using standard deviation as 6,000, determine the probability that the company will at least break even if existing printing facilities are used. The special machine is hired.
Okay, thank you. That's good. That's good, Christine. I think that is good enough for us to start there. So in this question, this one is a case of a single product. It is always good to classify these questions so that you know which formulas you're going to apply. Now, this question that we have read, there is just one product. They are talking of, they're introducing a new management accounting textbook. So it's a case of single product. It's a case of single product. And when you see probability, it is a case of uncertain conditions or uncertainty. Uncertainty, CVP analysis. When you identify the question belongs in which of the 4 categories that we have mentioned, that will help you to gather the formulas. So we are told that the book sales, they have a mean of 20,000. And it is determined that there is a probability of 0.5 that they will lie between 16 and 24,000. So we will come here and say normal probability distribution. Probability distribution for books. For books, I told you when you are given normal probability distribution, I think we came across this when you were in inventories. You draw a normal curve like this. That's what we call a normal curve. And I told you here at the center, we put the mean, the expected value of X. And here we put the standard deviation. We put the standard deviation. So we are told here that these books are expected to be between, so this one we'll call it X1, 16,000. This is 20,000. This is X2, 24,000. Now we are told here there is 50-50 chance. So if it is 50-50 chance, and it's supposed to be divided into two, then this one is 0.25, and this is 0.25. So this is the value that we are supposed to look for. That is the one that is unknown. That is the one that is unknown. The one that is unknown. I told you that these are probabilities. These are probabilities. And we need to recall that Z1 or Z is given as X1 minus X bar, you divide by standard deviation of X. You divide by standard deviation of X. So what we are missing is this X. So we seek to make it the subject. So it will come here and this one to come here. So you'll say standard deviation of X should be equal to X1 minus X bar. You divide by Z1. That is how we shall get the standard deviation. So we already know X1 is this. We also know X bar is 20. So what we are missing is Z1. So we will say from the tables, Z1 is equals to, and I told you when we came across this, that when the value of X, X1 is on the lower side of the mean, it becomes negative. But when you are on the upper side of the mean, it would have been positive. So this one, we will say it is negative because you're on the lower side. So take your tables. Take your tables. Let's go to the tables. Normal curve. Let me remind you how to read again. Normal curve. So go to where it is written normal curve. Normal curve. You're in. So I told you how to read this is you get inside here. You look for this value, 0.25. You may not get it exactly. You may not get it exactly. You not get it exactly. So you pick the value that is closest. Ukishapata ile iko closest, unisomee the value that is in the row hapa, ukifuata the value in the row and the value in the column where you have found that. So tell me that value. Mpaka hiyo figure itoke kwako ndio nione kama tunaelewana. Yeah, you can either take 0.68 or 0.67, either. So let me go with the one given by Christine. Good. Even Kerubo, good. So 0.68. So if we know that, we proceed now and say standard deviation of x. Standard deviation of x is x1 is 16,000 minus 20,000. You divide by minus 0.68. You divide by that. $58, 82.35. 58, 82.35. Now, in terms of thousands, if you round up to the nearest thousands, this will be approximately equal to 6,000 units. So that is what the examiner wanted by saying that you prove. By saying that you prove, acha nirudi mahali hiyo swali ilikuwa. You prove that the standard deviation is 6,000. The next thing is, using standard deviation of 6,000, determine the probability that the company will at least break even if they are using existing printing facilities. So normal probability distribution for so hii itabidi ni rabi yote. So probability of breaking even. Probability of breaking even. And this one, we are doing it with existing facilities. Existing facilities. Now, the first thing that you need to do, is to say at break-even points, profit or the expected profits should be equal to 0. You should know that. That's what you have said. At break-even point, profit is equal to 0. When you are in the case of SIGO and certain CVP, expected profit is given as the contribution margin multiplied by the expected units minus F. Expected profit is equal to contribution margin, expected X minus F. So how do we get contribution margin? Contribution margin to tumesema it is the selling price minus variable cost. The selling price minus variable cost. So we are told that this book, it will sell for 1,000 per copy. Then we minus the variable cost. The variable cost, we have 10% of royalties. 10% of royalties. Plus, there is another variable cost. The variable cost of production is 400. So work that out and tell me what is the answer. This is the selling price. This is the variable cost that is giving us contribution margin. Okay, so this is supposed to be 1,000 minus 0.1 of 1,000 minus 400. That is giving me 500. So that is the contribution margin. So my expected profit, will be 500 times the expected units. The expected units is the mean, is the X bar, which is 20,000. It was our X bar. And the fixed cost, we are told that the fixed cost of doing all this is 2,500,000. 2,500,000. So if you consult your calc, it will help you to know that this times 20,000 minus 2.5 million, you will get 7,500,000. So that is the expected profit. Now, when you're looking for the probability, there is something else that you require to get. The standard deviation of the profits. The standard deviation of the profit when you're in the case of SIGOs, we say the contribution margin, you multiply by the standard deviation of sales. Then the standard deviation of sales units. If you look at the symbols that I've given you. So this one will be 500. You multiply by 6,000. So if you check in your calc, 500 times 6,000 is 3 million. So sasa we can draw a normal curve. The normal curve for the profit. So this is the expected profit, which is 7.5 million. 7.5 million, this one. Then the standard deviation here of the profit, it is 3 million. And when we are told to look for the probability of breaking even, it is the pi 1 here, which is 0. Because at break even, profit is 0. So the probability that you break even is the probability that you make more than 0 profit. So more than 0 profits, you shade this region. This is what we are interested in. That is what we are interested in. That is what we are interested in. So ukishachora hivyo, we compute Z. Z1 will be equal to pi 1 minus the expected pi. You divide by the standard deviation of pi. Ni kama tu ile formula tumekuwa nayo kwa units, is only that now we are using pi instead of x. So Z1 will be now 0 minus 7.5. You divide by 3. So tell me what that value is. Actually, when I use my calc, I'll say 0 minus 7.5 divided by 3 is negative 2.50. It's negative 2.50. Negative 2.50. Ukishapata hii, ndio unakimbia unasema from the tables, probability that pi will be greater than or equal to 0. Probability that pi will be greater than or equal to 0. Now, nataka urudi kwa hiyo table ya normal. Rudi kwa hiyo table ya normal. When you go to that table, obviously here it begins with 0.0. Na here kwa column zimeanza at 0 all the way to 9. In the other one, tulikuwa tunatafuta huku ndani because we have been given the probabilities za huku ndani. Saa hii now tuko na value of Z. We want to know the probability. So what you do, you go to where it's written 2.5. So tafuta mahali kuna 2.5 hapa. Add 0. So where they meet here, where 2.5 and 0 meet, read for me the value that is there. $0.4938. Good. 0.4938. Now, anytime you go and read in the tables, the answer you get is always the probability from the center to where your x1 or pi1 is. So this is the probability kutoka hapa mpaka hapa. But we also want this one. And you remember I told you the other day, normal probability is called normal because it's metrical, divisible into two equal parts. So kutoka hapa mpaka huku mwisho ni 0.5. Kutoka hapa mpaka huku mwisho ni 0.5. So now that hii tunataka yote, you can see it's shaded kila mahali. So we add 0.5. Add 0.5. So this gives us a probability of 0.9938. We are told to do the same with the special machine. So tunarudia the same process. So rudi hapa juu useme probability of breaking even. Special machine. Probability of breaking even. Special machine. Just mine, I'm just grabbing what will change. So probability of breaking even. And this is when we use the special machine. The special machine. So you can repeat these things or you can skip. They remain at break-even point, expected profit is 0. Expected profit is given as contribution margin multiplied by expected units minus F. So in this case here, the selling price remains 1,000, but the variable costs will now be 10% of the 1,000 and not 400 now, but 250. So that will give me 1,000 minus 0.1 of 1,000 minus 250 is 650. So the expected profit now will be 650 minus the fixed cost. The fixed cost, tuko na ile ilikuwa ya kwanza 2.5 million plus inaongezeka na 1.4 million. $1.4 million. So 9,100,000. So this will be 650 times 6,000. So ukuja uchore hii table, this is 3.9. This is 0. This is now 9.1. Hebu endelea na hiyo unipatie hii. Aone kama tufuata. So what are you getting here? $2.33. $4901. So 0.4901 plus 0.5. So that gives us 0.9901. Okay, so we are going to stop there for now. We shall do some more in our next lesson. The next lesson will just be questions on CVP. Yeah. So just read those formulas. We prepare for our next lesson. That would be good. Thank you. Good night.